Alright guys, so again a quick review from Friday, domain and range. So domains are your x values. Okay, another word for domain is input. Alright, or an independent variable. Those all mean the same thing, those all mean x. Alright, and then range is all of your y values. Another word for range is the output or the dependent variable. Yes, Dara? Touche. I'm not writing anything, I'm just talking, but touche on that. How about now?
I can see it.
Oh, perfect. Alright, so again, domain is all of your x values, range is all your y values. We talked about two types of functions. Okay, we talked about the continuous functions and we talked about the discrete functions. Okay, discrete functions are a list of points. Continuous functions are obviously continuous across a certain line segment or a line. Okay, we're going to talk about both. We're going to review both today. All right, so if I'm looking on the left side, these are discrete functions, okay, or discrete relations. All right, and again, the way we list domain and range for a discrete relation is we use a list. Okay, the way we list discrete functions, domain and range for discrete functions, is we just list the points out. All right, so for my domain, I'm looking for all the x values. So I'm looking at my points here. So I'm going to pull the 2, I'm going to pull the 7, I'm going to pull the -3, the 7, and the 5. All right, and again, the way we start our list is we use what we call a brace. I looked it up. All right, I called it a little squiggly thing, same thing. All right, so we're going to start with our brace, and now we're going to go in ascending order, right? So least to greatest. So the least number I see out of 2, 7, -3, 7, and 5 is -3. Then I'm going to go to the 2. Then I'm going to go to the 5. And last is the 7. All right, we have 2 7s. Just list it one time. I'm going to do the same thing for my range. My range is my y value. So now I'm looking at 0, -1, -7, -4, and -3. So again, open up your range with a brace. And I'm going to write them in ascending order. -7, -4, -3, -1, and 0. So there's your domain and range. Okay, now again, we want to determine if it's a function or not. So just a review over functions. Okay, and how I determine if it's a function or not. Your x value cannot map or repeat to a different y value. Okay, so your x value cannot repeat to a different y value. Well, if you're looking here, you have a x as 7 and it matches to -1. You have an x of 7 and it matches to -4. So this is not a function. Why? Because again, your x matches to a different y value. So if you were to draw a vertical line using the vertical line test, like I said on the do now, if you were to draw a vertical line through the point x equals 7, you would touch that vertical line twice. Okay, Dar, you still have a question, or will you put your hand down for me? No?
Sorry, I don't have a question.
Okay, rock on, no problem. Give me... Anna, you there?
Yes,
All right, Anna, can you help me out with number 2, the domain for number 2?
yes. Okay, so the first one is -9, -8, -7, and -6.
Perfect. What about the range?
-2, 0, 8, and 9.
Awesome. Okay, Anna, one more. Is it a function or not?
It is a function.
Fantastic. Fantastic. All right. What about Ishal? You there?
Yeah.
Is your camera on, Ishal? I can't see you.
No, it's not.
Do you not have a laptop, Ishaw?
I do, but I use it for school.
Oh, okay, you're not on the same. I got you. Okay, Ishaw, can you help me out for number 3 then? What's the domain?
The one under it,
Yes, ma'am.
you have to scroll down and do it.
You see now?
Yeah.
Okay, perfect.
9, 5.
Okay, so again, you're right. Okay, but we want to write them in ascending order. So I need the least number first.
1,
Perfect.
5, 6, 9.
Great job. What about the range?
2, 4, 6, 7, 9.
Good. Okay, last question. Is it a function or not?
No.
Why is it not a function?
There's 2. Wait. There's 2 exam y values.
Okay, but again, the what I need, okay, the determining factor is if any of my x values repeat to a different y value. Okay, so do any of your x values repeat, Ishaw?
No.
Okay, so it is a function. Okay, and that's a good point. Okay, my y's can repeat just as long as my x's don't match to a different y value. All of these could be 6. All of these y values could be 6, and it'd still be a function. Okay, but again, my x values cannot repeat to a different y value. All right, thank you, Ishaw. Gollum, hop on.
I can't really see it that well.
What about if I zoom in?
Alright, yeah.
Is that no better?
Yeah, it's better.
All right. So give me my points, Gollum. What is this? I go over 1, 2.
Negative 2, 1.
Perfect. Okay, what about this one?
0, 0.
Okay, I'm going to ask you, what do we call that point 0, 0? Starts with an O, ends with origin.
Yeah, origin.
All right, perfect. Okay, what about this point? I go over 1, 2, 3, 4, 5. Go up 1, 2, 3.
4, 5, 4.
All right. What about this one?
7. And the other one is 7, 6, I think.
Perfect. All right, so now let's list our domain.
Negative 2, 0, 5, and 7.
Awesome. Range?
0, 1, 4, 6.
Yep, sorry. Last thing, is it a function or not? Why not?
Because it has the same x values.
What x value?
7.
So again, if I was to draw a vertical line through x is 7, you see how it touches that vertical line twice? Therefore, it is not a function. Okay, again, if it touches the vertical line twice, it is not a function. Or if any of my x values repeat to a different y value, it is not a function. Cameron, do you mind taking that hood off, bud? Thank you, man. All right, let's go over here to the right side. Okay, so these are continuous functions. So we had discrete on the left side, and it was just a list of points. Now we're going to talk about continuous functions. Can anyone remind me, how do I write domain and range for a continuous function? Just hop on and tell me.
Like, if you're going to do it for y, you do the y for the first one over there, and then you put equal to, or you put that one is equal to, and then you go to the other one. That makes no sense. Sorry.
Okay, but I'm looking for one word expressed using. Somebody talk to me. Yeah, I'm going to do it using inequality. And so, Camila, what you're saying is, I'm going to start, okay, at one point, and I'm going to end at the ending point. Same thing. If I was talking about the range, I'm going to start at the bottom point, and I'm going to end at the top point. Okay, so again, we're going to list it a continuous function. we're going to list the domain and range. We're going to list the domain and range as an inequality. Okay, as an inequality. All right, so if I'm looking at number 1, the first one, okay, you're going to start, domain and range, you're going to start on the left side of the graph. And I want to know, what is the leftmost point on the graph? So the leftmost point on the graph is this point right here. All right, so I'm going to look at my x value at that point. So we're going to go over 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6. So that point is -5, -6. And again, all I care about is the x value, right? Because I'm talking about the domain. So my domain starts at -5. Okay, now we're going to express it as an inequality. So when you're looking at inequalities, there are 4 inequality symbols. Less than, greater than, less than or equal to, greater than or equal to. Okay, but I'm going to throw out 2 of them, and I'm only going to give you 2 options. Less than, or less than or equal to. All right, so you got a 50-50 shot. Okay, so again, we're choosing less than or less than or equal to. Can anyone remind me, how do I tell the difference? Yes, Dara.
If the circle is shaded in or if it's not.
Exactly. So if the circle is shaded in or it's not. Okay, so I'm looking at number 1. Okay, or the first one, whatever. All right, so at that -5, Dara, is that circle shaded in or not?
No, it's not.
Okay, so if it's not shaded in, what am I using?
Less than.
Awesome. So -5 is less than. And again, we're talking about the domain, so I need the x variable right there. And now I'm going to end at the rightmost point on the graph. Okay, I'm going to end at the rightmost point on the graph. So the rightmost point on the graph, I scroll over. Sorry. Okay, I scroll over here. All right, and the rightmost point on the graph is right there. So again, we're going to go from the origin, 1, 2, 3, 4, 5, 6, and then up 2. So that point is at 6, 2. And again, I'm talking about the domain, so all I care about is the x values. Right? I'll care about the x value. So I'm going to care about the x value at that point, which is a +6. All right, Dara, can you help me out? What symbol would I use there?
You would use the less than or equal to sign.
Fantastic, because again, that circle is shaded in. What that circle tells me is that line touches at that point. That line touches at that point, so it is included, so it is equal to. It satisfies that inequality. Okay, now we're going to go to the range. So again, the range is the y variable. Okay, so instead of there being an x here, there will be a y here. Now I'm going to read the graph from bottom to top for the range. Okay, I'm going to read the graph from the bottom to the top for the range. All right, so the lowest point on the graph is going to be right here, same point. Okay, but again, the range is the y value, so it's -6. That's still an open circle, so it's not equal to. And now I find the highest point on the graph, which is going to be up here, at a +2. And again, Dara tells me that that circle is shaded in, so that circle is equal to. The inequality symbol is equal to. Great job. Okay, so let's go to number 2. All right, let's grab our point here. So our point is at over 1, 2, down 1, 2, 3, 4, 5. So I'm looking at -2, -5. Okay, and then look over here. That's an arrow. Okay, can anyone tell me what that arrow means?
Is it continuous?
Yeah, it means it keeps going. Okay, it means it keeps going. So if it keeps going to infinity, okay, infinity is not a number. Right? Infinity just keeps increasing. Okay, that's why they say to infinity and beyond. Okay, because they're going to keep going. Okay, so if infinity is not a number, there is no way for me to choose the less than or equal to sign. So you know right now that anytime you choose the infinity symbol for domain or range, your inequality symbol will not be equal to. Let me say that again. Anytime you write the inequality symbol or the negative inequality symbol, your inequality symbol will not have a line underneath. Because inequality is not a set number. So you cannot be equal to something that's not a set number. All right, so let's look at what that looks like. Sorry, I got people trying to get in still. I don't know why it's not acting up. I mean, is Andrew H. still trying to get in the meeting? Because he's not waiting in the lobby or nothing. Okay. All right. So here we go. Domain. Okay. So again, I'm going to scan the graph from left to right for domain. So I'm going to start at the leftmost point, which is right there, which is a -2, less than or equal to, because that circle's shaded in. I'm talking about domain, so I need the x variable there. And then now I'm going to find the rightmost point on the graph. So the rightmost point on the graph is right here. But once again, there's an arrow there, so that line keeps going. So that line is going to go all the way to infinity. So my infinity symbol is like a sideways 8. Looks like that. Okay, or if you need to, just write 2 zeros beside each other. And again, the inequality symbol in between those is going to be less than. All right, so now I'm looking at the range. The range I'm going to scan from the bottom to the top of the graph. So the lowest point on the graph. Yes, Amina, she's emailing me. I don't know what's going on with her. The lowest point on the graph is right here. Again, the y value at that point is -5. Again, it's a closed circle. So my inequality symbol is equal to. And then now I'm looking at the highest point. So again, the highest point on the graph has an arrow there. So that line's going to keep going up and to the right. So that line's going to keep going all the way to infinity and beyond. So there's your domain and range. Okay, so this is something that we didn't really get to on Friday. Yes, Jessica.
I wasn't here last class, so I don't know if you explained this, but the assignment we did about domain range, the one where you have to pick the options at the bottom, there was no infinity sign, so I didn't know what to put when it was the line continued.
On which number?
Just like when the graph continued with this arrow here, there was no infinity sign in the options, so I didn't know which one to pick.
When you were trying to fill in the blank or what?
Yeah.
Okay, were you using your phone?
No.
You using a laptop?
Yeah.
Yeah, you should be able to insert a symbol. I'll have to show you that later. Okay, you can insert an equation. All right, so I'll show you that later. Good question, though. All right, last one on this page. Okay, so I'm looking at, this is what we call an absolute value function. Okay, no big deal. All right, so I'm looking at domain and range. So if you're looking at your function here, this has an arrow, this has an arrow. So again, both of those lines are going to keep going. So Jessica, if I answered your question, will you put your hand down? Perfect. So again, both of those lines are going to keep going to infinity. Okay, so again, my graph is going to start at negative infinity. Okay, because I don't have a point to start at. That line keeps going. So you're starting at negative infinity. Okay, and then now I'm going to stop at the point on the right side. Okay, well that line is going to keep going also. So you're going to stop at positive infinity. Both of those are not equal to, because infinity is not a set number. So my domain is from negative infinity to positive infinity. Okay, a huge note here, guys. You can never start your domain or your range at positive infinity. Okay, so you see how I have a negative in front of this sign? If you leave that negative off, that's wrong. You're not starting your domain at positive infinity. Positive infinity is over here. The graph will never start at positive infinity. The graph could start at negative infinity, yes, just like this one does. Or any number in between, but it cannot start at positive infinity. Alright, so a good way to check yourself, if you have an infinity symbol over here on the left side, it's got to have a negative. It's got to have a negative. Okay, perfect. Alright, let's look at the range. Okay, so I'm going to scan the bottom to the top of the graph. Okay, the bottom, the lowest point on the graph is right here. It doesn't start at negative infinity. So I need that point. So I'm going to go down 1, 2, 3. So that point is at 0, negative 3. So my range starts at negative 3. And it's a closed-in circle there, so it's touching at that point. So it's equal to the range, which is the y variable. And both of these lines keep going up. So my range keeps going all the way to positive infinity. So let that sink in for a little bit. Okay, questions. What questions do we have on continuous graphs and domain and range going to infinity or negative infinity? Because that's new. Yes, Dara.
So you said that when you start the domain, it always starts with a negative infinity?
It does not always start at the negative infinity. Okay? I'm saying that if there is an infinity symbol here, it has got to be a negative. There's no way that your domain or range can start at positive infinity. So if you choose infinity on the left side, it's got to be a negative. Okay? It doesn't always start at infinity. Look at this domain. It started at negative 2. Okay, I'm just saying that if you're choosing infinity over here, it's got to be a negative. It's got to be a negative if you choose infinity. Does that make sense? All right, good. Gollum?
Can you end up with the negative infinity?
You can never end. Good question. You can never end at negative infinity. Just like you cannot start at positive infinity, you can never end at negative infinity. Good question, Gollum. Taylor, yes, ma'am.
How do you know when to put greater than and less than, like, or greater than equal to? Like, does it, like, it differs?
Okay, so Taylor, I'm going to stop you there because I'm never going to choose greater than. Okay, I'm never going to choose greater than, right? I had two options. First option was either less than. Second option was less than or equal to. Okay, so right now I narrowed it down to 50-50. You got two chances. Okay, now Dara, will you hop back on and tell us what you said? How do I choose? It was you, right?
Yeah.
You tell me how I choose. How do I choose? How do I choose whether that is a closed-in? I'm sorry. I'm giving you the answer. How do I choose which inequality symbol?
If the circle is closed, it's less than, and if the circle is, no, if the circle is open but not colored in, it's less than, and if it's colored in, it's less than or equal to.
Okay, so Taylor, does that make sense? Okay, so look here, Taylor. That's a closed-in circle, right? It's shaded in. So that is telling me that that line is touching at that point. So you have got to include it in your inequality. That's why I put that line underneath. Okay, but if you look up here, this one's an open circle. So what that's telling me is that line is going to get really, really close to that point, but it's not really touching at that point. Okay, so that cannot be included in your inequality. So it is not equal to that negative 5. All right, so look at your point. If it's closed in, you're going to put a line underneath. If it is not, if it's an open circle, you will not put a line underneath. What else? Gollum, you good? If you good, put your hand down. Taylor, you good? Perfect. Perfect. Okay, so now let's go to the Taylor, you good? Okay, put your hand down, please. Let's go to the first page of notes, and I want to go all the way to the bottom. We're going to work these 4 examples. Hey, Andrew. Andrew, what's up, buddy?
Finally.
What's going on?
Yeah, I was on Steam, and it's the Wednesday one. I was accidentally joining, I think.
That's why I put the link in the chat, dude.
It wasn't there for me.
Alright, so again, let's go back to the first notes. We're looking at the bottom 4. Okay, so if you want to pull that up, if not, it's right here on the screen for you. Alright, so we're looking at domain and range. All 4 of these are continuous functions. All 4 of these are continuous functions. So I know right now that I'm going to write them as an inequality. I'm going to write them as an inequality. For continuous functions, I always write as inequalities. Graham, you there? All right, Graham, let me give you these 2 points. Okay, this point is at negative 5, 4. This point is at negative 2, 4. Graham, I want you to help me write my domain for the first one.
Okay, your domain, negative 5.
Okay?
And there would be a less than sign.
Okay?
And there would be a negative 2 sign.
Okay, what goes here though?
Which means X.
Okay, X, perfect. And then what? Where does it stop at?
Oh, yeah.
Okay. What about what goes here?
Less than.
Less than. Hamza, do you agree? Okay. All right. Hamza, I want you to do the range, and then Graham, I'm going to ask you if you agree. Sorry.
Four.
Okay. Negative 4.
Negative 1. Less than.
Good.
Line.
Good.
Less than. 1.
Graham, you agree?
No, I thought it. Oh, wait, yes.
Okay, Dara, you're shaking your head. Why are you shaking your head?
Wait, no.
I thought we start from top to bottom. I thought it would start with the positive 4 then end with the negative 4.
Graham, do you agree with Adara?
Yes.
Okay, so let's look back at all our other problems, right? So I'm going to go back to our other page. Do I ever start and go backwards? Okay, so again, I'm looking at domain. I'm scanning the graph from left to right. All right, so I want the leftmost point, the lowest value, and I'm going to write it to the highest value. Right, so I said with the word ascending. I'm going to write it in ascending order. So I wrote it from negative 5 to 6. So you notice that I started here on the left side, and I wrote it to the positive side, okay, or the highest number. Same thing with range. I started at the lowest point, and I went to the highest point. Right? I'm going to write it in ascending order. So I'm always going to get bigger. So Dar, take what you said, and we're going to do the exact opposite. I'm going to write it from least to greatest. Okay, so this is correct. I'm going to write it from -4. My range goes from -4, the lowest point, and it ends at +4, which is the highest point. So the highest point. Okay, and what do the open circles indicate? It indicates a less than sign, right? Or it does not touch. Doesn't touch at that point. Ilm, you there? Okay, Ilm, I'm going to give you your 2 points, and I want you to help me write my domain for the second one.
I got -4.
Okay?
Less than x. And then less than infinity.
Noor, are you there?
Yeah.
Do you agree with that?
Yes.
Ilm, that's a great job. Okay, so I start at our our lowest point for our domain, which is right here. It's an open circle, so you know right now you're using a less than sign. It's not equal to. Okay, I need the x value at that point, which he chose was -4. Now, look over here. I'm going to stop at my rightmost point. But there's an arrow there, so that tells me that that line's going to keep going all the way to positive infinity. Infinity is not a number, so it cannot be equal to infinity. That's where he got that symbol right there. Great job, Ilm. Noor, I want you to do the range.
So -1
Good.
less than y less than infinity.
Ilm, do you agree?
Oh, yeah.
Fantastic. Great job, guys. So again, that's what we're learning new today, the infinity symbol. So again, the range goes from the bottom to the top of the graph. So Dara, I see you still shaking your head, girl. I'm looking at the lowest point on the graph. And I'm going to the highest point. Range goes from the bottom to the top. Domain goes from left to right. I'm always going to write them from least to greatest. So the lowest point on that graph is right here. So the range starts at -1. And I can see it's an open circle, so I know right now that I'm using a less than sign. It cannot be equal to. Why? Because the open circle indicates that my line doesn't touch at that point. So I'm going to choose my highest point on the graph. Well, if I look at the highest point that I see on the graph, that point right there has an arrow on it. So that tells me that that line keeps going. It keeps going, keeps going, keeps going, all the way to positive infinity. Anytime I put an infinity symbol, you cannot put an equal to sign right here, because infinity is not a set number. Infinity keeps changing. That's where I got my range at, -1 to infinity. Perfect. So what would the arrow indicate? The arrow indicates we're going to infinity or negative infinity. The arrow indicates that the line keeps going to infinity or negative infinity. Mahir, you there? Okay, Mahir, can you do the domain for the bottom left one for me?
2, 0.
Okay, that point you're talking about?
Yeah.
Okay, that point is at 0, 2. Remember, I'm going to go over before I go up. Okay, so that point is at 0, 2. All right? All right, so let's list the domain. The domain, Mahir.
0 less than x.
Okay.
Less than negative infinity.
Okay. And again, Mahir, you corrected yourself, but a good note, okay, you can never end at negative infinity.
Yeah.
So you corrected yourself. Okay, so Namdi, you there?
Yeah.
Namdi, do you agree?
No.
What do you not agree with?
Wait a second. Wrong.
Okay, Namdi? I don't agree. So can you tell me why I don't agree? Can you look at that and tell me where we went wrong? Again, I'm going to start on the leftmost point on the graph. Okay, well, we're starting at 0 right now is what y'all are telling me. Okay, but I've got a point right here at -1. I've got a point over here at -2. I've got a point down here at -3. I've got a point down here at -4. That arrow keeps going. -5, -6, -7, -8.
So negative infinity is less than x, less than infinity.
So now, Mayer, I'm going to come back to you. Do you agree with what Nambi just said?
Yeah, I realized it wasn't like a actual point there, like a dot.
Okay, well, it is. It's an actual point. Okay, so don't say that. It is an actual point, but that's not the least point, right? Because I got a point right here, and that's left on the. That's more than on the. Sorry, that's less than that point.
Okay.
So I'm scanning the graph from left to right, right? Okay, so the graph starts down here. It doesn't start right here at 2. I see the graph right here. So I can't just skip this piece of the graph and go straight to that point right there. That'd be like if I went up here and I started at this point right here. There's a point right there, yes. There's a whole bunch of points. There's an infinity many points on this line. Line segment, excuse me. Okay, but the graph starts over here. Same thing here. The graph starts over here. I can't just pick that point. That's in the middle of the graph. All right, so now, Namdi, I want you to help me with the range. Namdi, there?
Yeah.
Okay, Namdi. So again, the range. I'm scanning the bottom to the top. So I need the lowest point on the graph.
Negative infinity less than x, less than infinity.
Okay, Mayer, you there?
Yes.
Okay, Mayer, do you agree?
Yes, I do.
Okay. I don't agree, Mayer. Okay, and what do I not agree with? Could you tell me?
I'm guessing like x being
Okay, awesome. That's one of the ways we went wrong. So that needs to be a y because we're talking about the range. Good catch. Okay, I also don't agree with one more thing, Mayer.
I can tell you what I did.
Namdi, what's up?
It should be negative infinity is less than y, less than 2.
So let's change this to a 2. Almost. Almost, Namdi. Look at this sign right here. Why do I need to change that sign? Is that an open circle?
No.
All right, so that circle is closed in. That means it touches at that point. If it touches at that point, I need an equal sign underneath my inequality. Good. Thank you for correcting yourself, Namdi. Perfect. Now I agree. Taylor, you there?
Yeah.
Okay, Taylor, can you help me out with the range for the last one? So let me give you your points. Okay, here's your origin. So we're going to go over 1, 2. We're going to go down 1, 2, 3, 4. So that point's at -2, -4. And then we're going to go over 1, go up 1, 2, 3, 4, 5. So that point is at 1, 5.
Since moving -4,
Okay, we're talking about the domain first, remember.
-2.
Good.
Less than
Okay.
negative 1.
Okay.
Or
X. What goes here, Taylor?
less than.
Omar, hop on. Omar, do you agree? I don't agree, Omar. Can you tell me why I don't agree? Perfect. Perfect. Good, Taylor, and good, Omar. Okay, so now it's perfect. Domain. I'm scanning left to right. So I need the leftmost point on the graph. The leftmost point on the graph I see is right there. That's where the graph starts at. So I need the x value, domain, x value at that point, which is -2. Now look at the circle. It's closed in. My inequality symbol needs to have a line underneath. Domain is the x variable. And now we scan to find the rightmost point on the graph, which is at that point right there. The graph does not continue past that point. Why? Because there's a dot there. It's a point. It's not an arrow. So it's not infinity. It's a point there. I look at the domain, the x value, which is +1, and it's a line underneath. It's less than or equal to because it is a closed-in circle. There's your domain. Great job. Uzman, you there? Okay. Yup. Uzman, you want to do the range for me? All right, Uzman.
-4 is less than or equal to y, which is greater than or equal to 5. Well, I mean, the other way around. Less than or equal to
Perfect.
5.
Riley. Do you agree with the range? Do you agree with Uzman? Coach Sapp agrees also. Okay, so again, the range, we scan from the bottom to the top. Why am I scanning from the bottom to the top? Because the range is your y values. Your y values run along the y-axis. Okay, so again, I'm going to scan the graph from the bottom to the top. So the lowest point on the graph is going to be down here. That is a point. That is not an arrow, so that does not keep going. So I need the y value at that point, which Uzman told me is -4. Perfect. Write it there. Now I look at the circle. It's closed in. There's an equal to sign underneath my inequality symbol. Talking about the range, so the y variable goes next. Now I'm going to find the highest point on the graph. So where does that graph stop at? That graph does not continue past that point right there. Right? I'm scanning bottom to top. So the graph goes no higher than that point right there. That point has a y value of 5. That's where I got the 5 from. Okay, and again, it's a point with a closed-in circle. So I have a equal to sign underneath my less than symbol. What questions do we have on this? Question? Hop on. Type them in the chat. Yes.
Okay. For the first one, I was a bit confused, but the reason why the domain started with the -5 is because of the lowest point on the graph, right?
Okay, again, domain goes from left to right. So I want the leftmost point on the graph. So I want what is the lowest x value that I have in my graph, which is the same thing as saying the leftmost point on the graph, which is that point right there. The x value at that point is a -5. That's where I got that from. I scan all the way to the rightmost point on the graph, which is the highest x value that I have, which is that point right there. It goes no farther to the right. So domain, scan across the x-axis. Range, scan like you're scanning the y-axis, which is why I'm saying bottom to top, left to right. Domain goes this way. Range goes up and down. Does that answer your question, Dara? Anybody else?